Welcome back to your favorite Fundamentals of College Math class. We're going to take a look here today. Let me grab my pen. At Venn diagrams with three sets is the only difference. So let's take a look. You know what? Let me come back to that. Let me look at this, a simpler example here with example one. Let's use this Venn diagram with these three sets, intersecting sets, to find, first of all, well, the regions that represent set A. So if we look at set A, right, here's set A, we have this region 1, which incorporates the number 11 and 3. We have region 2, we have region 5, we have region 4. So regions 1, 2, 4, and 5. In other words, if you are naming the members of the set, 3, 11, 12, 5, 7, 6, I guess I should put that in order. Okay, what about A union B? A or B, right? That means union, A or B. So we're in A or we're in B. So that's all of them. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Now, how about B and C? B and C. Sorry, I have my door closed. You probably hear my daughter playing in the background. Practicing her piano. All right, B and C. So here's set B. Here's set B, right? Here's set C. Who's in both B and C? So region 5 and region 6. In other words, the elements 5, 7, and 9. So regions 5 and 6. Or again, 5, 7, 9 are the elements, but those are the regions. How about not C? So if we're not C, so C's out, right? Here's not C, then we're 1, 2, 3, or 8. 1, 2, 3, or 8. And how about finally A and B and C? Who's in all three? A and B and C. That'd be right in the middle there. A and B and C. Can't see the middle because I have such a mess right now. A and B and C. Will be right there, region 5. Okay, so I go back to this here. We just talked about region 5, A, M, B, and C, but let's look at these ones in light blue. Let's kind of walk through the elements in both sets. Both sets A and B, they're not in C. So here's how it's represented. You got to be in A and B and not C, so the complement of C. So let's first of all, let's do A and B. Who's in A and B? So now you're looking at 2 and 5 because you got to be in both there. So here's your regions 2 and 5. Now we're going to find the intersection of that with who's not in C. Well, here's C. So who's not in C? 1, 2, 3, and 8. 1, 2, 3, and 8. Now, who's in both of them, right? Intersection and. 2's here, and it's here. So 2's a winner. 5's here, but it's not over here on the right-hand side. 1's here, but it's not over here. So on. So 2's the only winner here. That's why it's saying region 2 is represented by that. And that's kind of how you're walking through these. Let's do one more here. How about region 7 here? It's represented in Y. So this region represents the elements in set C that are in neither A nor B. In other words, C and, this is another way to say it, not A, complement of A, and not B. So let's go ahead and do not A first. So not A would be 3, 6, 7, 8. 3, 6, 7, 8. And now I'm going to do not B. So not B now, not B. So that'd be 1, 4, 7, 8. 1, 4, 7, 8. Okay, and I haven't done it with intersection. All right, so we're doing this side, this right hand side. So 3, 6, 7, 8, and it's got to be with 1, 4, 7, 8. So the only winners that are in both are 7 and 8 are in both. Okay, so we've done this. Not A with the intersection, not A, not B. But who's in C? So C is, can't tell. So here's C. We got 4, 5, 6, 7 are in C. So who's in C and 7 and 8, right? I got to be in both. So 7's in both. That's the only one that's in both. All right, so 7's our winner. So just this white one. That's the one that represents C and the intersection of not A and not B. That's what those are walking through. All right, we'll walk through those. All right, so let's do it given the universal set 1 through 9. You've got A, B, and C. What I would suggest is if you're going to try, you should draw these out. They're nice. It's nice to see the visual of these to kind of help you out rather than always just doing it in roster form. So notice A is 1, 2, 3, 4, 5, B is 1, 2, 3, 6, 8, and C is 2, 3, 4, 6, 7. So the first thing I'm looking for is who is in all three. Here's A, B, C. Is there any that A, B, and C share? Looks like 2 is in all three. It looks like 3 is in all three. So those are the only ones that are in A, B, and C. Now I'm going to move to, let me do the ones that are in A and B. Well, obviously 2 and 3 are both in A and B, but also 1 is just in A and B. I'm going to put that 1 right there. Now I'm going to look for which ones are in B and C. So B and C, well, 2 and 3, of course, are in B and C, but also notice 6. 6 is also in B and C. So 2, 3, and 6 are in B and C, but 6 is the only in B and C that's not in A. Okay. Now let's find the one that's in A and C besides just 2 and 3. A and C besides 2 and 3. So A and C share 2 and 3, but they also share 4. 4. Okay, let's see what's left that we haven't put in here from this universal set. 5 I haven't listed. So here's 5. 5's in A, but it's not in any of the other ones. 8 is in B, but it's not in any of the other ones. 7's in C, it's not in any of the other ones. And then I got to check, is it 1 through 9, are they all listed here? Let's see, I got 1, 2, 3, 4, 5, 6, 7, 8. 9 is the one that's missing, that's in the universal set, but it's not in A, B, or C. Now I think I can answer this question, which says find A and the union of B union not C, or the complement of C. All right, let's do this right-hand side first. B is 1, 2, 3, 6, 8. 1, 2, 3, 6, 8. And I'm going to find the union with not C. So not C would be, all right, so I'm looking up here and I'm like, everything but not C, right? So 1, 5, 8, and 9 is left. 1, 5, 8, and 9 is left. 1, 5, 8, and 9. Now I'm taking the union of these, so it's just got to be on one side or the other. So they're all in. 1's in, It's on both sides. 2's in, it's got to be here or over here. As again, it's just got to be on one side or the other because this is a union. 3, 5, 6, 8, 9. So they're all in over here. And now we're going to do the intersection with A. Well, A is 1, 2, 3, 4, 5. Right? So I'm going to take the intersection and it's got to be on both. 1's in both, so 1's in. 2's in both, 2's in. 3's in both, 3's in. 4's only on the left side, 5's in both. So it looks like 1, 2, 3, 1, 2, 3, and 5 on that. Okay? And that just shows you the walkthrough there. All right, let's finish off here with, I've got to get back to my lovely blue. Just love my blue. Let's kind of walk through inductively at least A and the complement of A and B. The complement of A and B. So let's do the left-hand side and let's show it's equivalent to the union of the complement of B, A with the complement of B. Okay, so let's work with the left-hand side. First of all, who's in A and B? Well, 2 is in A and B, right? So if I'm going to take the complement of that, so not 2, then I'm left with 1, 3, and 4. 1, 3, and 4, right? Now, is that really equal to, if I was to work with this left-hand side, not A, so not A would be 3 and 4. And then not B so not B would be 1 and 4. And then I'm taking their union, so one or the other. So they'd all be in. So 1's in, even though it's on just on the right hand side. 3's in. 4's on both sides. That's great. So 1, 3, and 4. Well, sure enough, that is what you call De Morgan. That's one of De Morgan's laws. This is just the walkthrough of that. That's one of De Morgan's laws. And you could do the same thing for the other one there. The complement of the union of A and B is equivalent to the intersection of the complement of A with the complement of B. Again, these are called De Morgan's laws. Thanks for listening. That's the 3 Venn diagrams. You have to play with those quite a bit in the homework. See you next time. Thanks for taking notes.